So, welcome to lesson 2.1, page 74, and the scenario that you're looking at is a 747, like that one. 747s used to carry the space shuttle around, is climbing at a rate of 1,800 feet per minute. And they ask you some questions. So let's take a look at the questions they're asking. So they're asking what is the independent in that situation. What's the independent quantity? And if we think about that for a minute, we're going to come up with time, because the height is dependent on the time. So we know that that's the dependent, the height. In other words, if it's 1 minute, we know we're one place. If it's 2 minutes, we know we're another place, etc., etc. So we know that the independent quantity is the time, the minutes, and we know the dependent quantity is the height, how high we are above the ground. Okay? And they ask you to make a simple sketch. So here I made a simple sketch, and I put 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8 minutes, 9 minutes. Now you'll notice I put that on this line. This is the X line. Now, the normal thing to do is to put the independent variable on your X line. Your dependent variable, your dependent quantity, goes on the Y line, the line that goes up and down. So, and I did a simple graph. I did 1,800, 3,600, 54, 72, 9,000. Every time I'm increasing by 1,800. And if I were to graph that, you can graph it, it would look like it would just be steady. 1 minute, we're there. At 2 minutes, we're at about 3,600 feet. 3 minutes, 5,400 feet. 4 minutes, 72. 5 minutes, we're at 9,000 feet. When you do yours, you'll discover that those line up really well. In fact, if you were to use a piece of graph paper, it'd be a perfect line. Okay? Which gets us to the last question on that page. What function family is this problem in? And I think pretty much a dead giveaway. Given that when we do it, we notice that it's going to be a line, the obvious choice, linear. So, let's take a look at the next page, page 75. So go ahead and go on to the next video.